Hello everyone, welcome back to my channel Fuzzing Lab. Today we're going to attempt a TryHackMe's room that will assess your ability to exploit authentication process on web applications. This room is called Hammer. Now, keep in mind that if you haven't tried any other room, like enumeration and brute force, session management, JWT security, or vulnerabilities and MFA authentication, then I would suggest you try this room first to gain the basic understanding of this authentication mechanism and how to exploit them. After that, when you feel comfortable with these mechanisms, you can actually jump onto the Hammer room right here to see how well you can apply those knowledge to exploit those vulnerabilities on a real web application. Now, without further ado, let's get started. So we're in the Hammer room, and let's grab the IP address right here. To make it easy, I'm just going to put this one to the host file and then name it hammer.tryhackme so I don't have to retype the IP address over and over again. I don't have to worry about remembering the IP address either. Okay, everything looks good. Let's get started. We may also need burp sweep, so I'm going to start it for now. HTTP hammer.track. Okay, so it looks like there's no service running on port 80 or port 443. Let's do an nmap scan. Nmap. For those of you who don't know, nmap is a powerful tool that is used by red teamers to perform enumeration and reconnaissance on the target IP address. In this case, we're going to scan all the services running on this target hammer.tryHackMe, and then this flag right here, the -p specify the nmap command to scan all the ports on this target machine. -o specify the output file, which is the hammer.tryHackMe. So we don't have to rerun the command over and over again. All right, let's see what we have. Okay, we started the burp suite. Just going to leave this for now. TTP. Sure. There we go. So we get an SSH service running on port 22. We have HTTP. Okay. HTTP running on port 1337. All right, so we're able to get to the application. And then now we land on the application. Let's do some enumerations on the authentication process. We're on the login page already, so let's try to see if there's any useful error messages. Hello. Invalid username or email or password. So there's nothing we can extract from here. Let's move on to another page. Forgot password. Invalid email address. So this one tells us that it's possible that when we input a valid email address, we're going to get to another page, or we'll proceed to the next stage of resetting the password. So now our goal is to find what a valid username or email address is. Let's take a look at the apps. Well, the very first thing I think of is to look at the page source code. Now, you can press Ctrl U or Command U if you're on Mac OS, and then it's going to open the source code for you. Inspect the page source code. What about JavaScript? Here. Hidden field. So this looks like a form that will be popping up if you enter a valid email address. Okay. And beside this, there's nothing much. How about the home page? The login page. Again, Control U or Command U. Oh, look, what do we have? Directory naming convention must be HMR and then the directory name. Okay, so now let's try fuzzing the application. We're going to use ffuzz and then going to specify the word list. What do we have? Discovery, web content. Directory. Let's use this one. Now we're going to download that to our machine. So we got the word list. HTTP, not me. HMR. First. Okay, we've got a few directories. Let's put it down or note it down. Now, these folders are the user photos that are stored or present on a PHP server, CSS, JS images. A lot of times we don't find any useful information in these folders. The logs folder is going to be the unusual folder that is present on the application. However, to be thrown out, we always have to check all of the folders because right now we'll have 4 folders. It doesn't take us long to check all of them. So let's go through each of them. But in reality, when you have a list of folders, then you may consider skipping these folders because these are the default folders on the application. CS. Okay, there's nothing. Just a bootstrap. Same thing. We try JS. Still nothing special. Images. Do we have anything? All right, we only have one image. And the logs. The unusual one. Okay, what do we have? Web request is limit of 10 internal redirects. It's possible that the application has rate limiting implemented to prevent brute force attacks. So we keep that in mind. Client deny server configuration. Oh, look, we found a user. We found an email. Tester hammer.tryme. Found you. We also find some interesting directories. We're not sure what they are, but let's just write them down. In case we might need them in the future, we have restricted area. Right here, we also have protected admin login. The lockdown doesn't seem to be important, so yeah, we skip it. So admin login. Okay. All right, now we have the email address. Let's try reset the password. Tester at hammer. Key, we get a 4-digit code. Now we can try using burp suite to proof for this one, but because we'll have 160 or so seconds and burp community is a little bit slow, eventually the time will run out before the burp suite can complete the attack. So we're going to be using FFuff as another tool to actually proof for the OTP. In order to do that, let's try to get the headers and the request body. Inspect network tab. Let's try one more time. Right click this one and copy value, copy as curl. Over here, we're going to modify this one to be a F5 command. We need to generate a payload for the attack, which is the 4-digit code. Crunch 4. So what does this command do? The crunch command will create a list of 4-digit codes. This one, the first 4 is specify the minimum length, and then the second 4 specifies the maximum length of the payload. And then the values of the payload will be a combination of all the numbers in this string right here. All the payloads will be stored in this OTPs file. Okay, once we run it, payloads will be generated, and we can double check that by running the cat command. We can also verify that we have 10,000 payloads. Yep. Okay, so now we have the list of the payload. Choose. OTPs.text. OTPs.text. You hammer reset password. We don't need this one. Now, as a best practice, every time you specify an HTTP method, always go with the data. I don't know why it shows right here, but I always go with the data. Just want to make sure I don't forget it. Specify a little bit. This one is going to be the first value. HTTP user agent. Okay, we may skip this one. Except we may also skip this one. Language. Encoding. Yeah, we may skip this. We keep this one. Original, no. Referral cookie. I will keep the cookie section. The data is above. Data is right here, cookie section. All right, what happens if we enter an invalid code? Now, tester, I'm gonna try me. Invalid. Okay. So we're going to filter on the responses that has invalid. And we're going to run on the silence mode. All right, so let's get the cookie values of this section, and then we can actually run the command. Let's see, what do we have? Does it have? Yeah. So we have rate limited exceeded. Please try again. Meaning that the application has a rate limiting mechanism implemented to protect against the brute force attack. So in order to bypass this one, we have to add another header to the command, which is the X forwarded. So X forwarded for header. So basically, this header X forwarded for is a header that specifies the source of the IP address where the command is coming from or where the request is coming from. When the server take a look at the request, they see X forwarded for, it will say, okay, this is coming from this IP address. And by specifying this header, we basically rotating IP address. Now, in this case, it doesn't have to be the real value of IP address, but server application, they don't know that. They will assume that, okay, we have multiple requests coming from different sources of IP addresses. By doing this, we can actually bypass the rate limiting in the application. Let's try one more time. Now, to make it simple, we specify the X forwarded to be the same value of the OTP code, so it will rotate every request. Now let's start again. Another. All right, looks like we temporarily locked out. Let me reset the machine. Sorry, guys. We're going to change the IP address. So while we wait for the machine to restart, let's recap what we have found. We were able to find 4 directories on this application: CSS, JS, images, and logs. And out of these 4, the logs folder seems to be suspicious. And once we visit the logs directory, we were able to find several interesting directories: restricted area, admin login, lowercase or lowercase, and the protected directory near here. Also, from the log file, we were able to find a valid email address: tester@hammer.tryhackme, and this is where we stop. There was a rate limiting mechanism to protect against a brute force attack. Because of that, we have to reset the machine and try it again. Now, in real life, you're gonna have to wait for about 30 minutes to an hour before trying again. But be careful so you won't get blocked again. Let's see if we have a new IP address. Oops. GTP. I'm not trying. Okay, we have the ff command ready. We'll need to update the cookie values right here. tester hammer.tryHackMe. Now I make sure that the X forwarded for header is present so I don't get blocked again. Let's try it. And it's going to take a few minutes before we can get a valid OTP code. I'm pretty sure. Alright, now that you have learned, in order to bypass a really limiting protection mechanism on application, we can use the X forwarded header. It's very useful. This can also use to bypass the internal system. Okay, so your access is granted now. Password, let's do it. Let's change the new password to password. Now let's try logging in. Tester hammer.tryHackMe password. Okay, we got the first flag. Okay, so now you can see that I was automatically logged out. That's because the expiration date of the cookies was set too short that we weren't able to do anything. We can try login again and modify the expiration date of the cookie. Now we don't need to reset the password. It's tester hammer.tryHackMe, and password is going to be password. Now if you go to the cookie section, we have two cookie values, the PHP session ID and then the token ones. We're going to give it one more day. See, it locks us out again. Tester hammer.tryHackMe. Now immediately after you log in, you have to change the cookie expiration dates. Refresh the page and then you'll be able to stay logged in. ls submit. Okay, we find this one. Copy. Let's see what does it have. GP hammer. Sure. Okay. So this is the content of the key file. We also notice that there's a JWT token right here, so let's see what it is. JWT.io. Okay, let's see what do we have. We have key. So let's try. And we know that this is located in the HTML folder. This is going to be the key. We change the role to admin. Now the remaining question is, do we change the email address or no? Well, sometimes you have to change to the admin at hammer.tryhackme to see if it works, but we're not sure whether it's on the application or not. Okay, let's find out. And open a new private window, http hammer.tryhackme 1337. And let's see if we have the admin hammer.tryhackme. Nope, the email doesn't exist. So we're going to keep the email address. Here we change everything. Paste it. Refresh it. Can we still run the command? Okay, we can still run the command. What do we need? Try. Okay, command is not allowed. Now up to this point, everything we did was correct. And now we are not able to run a command. My suspicion is the front-end application is blocking me using this command. So I'm going to bypass these front-end defenses by using Burp Suite. Now let's capture traffic first. Submit. It is intercepted. Send it to a repeater. Okay, we submit a ls command. We get a content, right? So how about we try cat home ubuntu flat.text. Command not allowed. Okay, there's gotta be something that we did wrong here. Now, if you notice in the cookie section, we have the regular cookie section. We also have the token right here. This token seems to be the correct one, the one that we modified. Can actually confirm. Yes. This is the one that we modify. And then over here, you see the authorization bearer. The value is different. So I think we have to send the modified token too. Now let's try one more time. And we got a flag. Right, so we were able to complete the room. So the reason we weren't able to execute the command on the front end was because this authorization bearer right here. There's no way on the front end that we were able to modify this authorization header. So we have to use Burp Suite in the back end to modify these values as well as the token value. And then we can actually execute a command. It's a little bit tricky. All right, so we have completed the room. Once you get a concept, everything is straightforward. There's nothing really tricky. The only thing that you have to pay attention to is, when you explore the JWT, sometimes you can't really do anything on the front end because you have to modify the request, the headers in the backend, and then in order to do that, you have to use Burp Suite. All right, and that's it. If you have any question, feel free to reach out to me. Bye.